Ethan, what's your question about milestone 3? Yes, I will. I'm about to talk about milestone 3 here in a second. So let's get to talking about that. Milestone 3. And let me pull up the chat window as well. And the participants, just in case anyone comes late, I can let them in. Okay. Milestone 3. Milestone 3 is your game's alpha release. This is it. We are at this point finishing up the game. You've got the basic parts you need for a dungeon crawler. You've got a combat system and you've got an exploration system. Now we're going to start putting that together into a full game. So I talk a lot about here. I'm not going to read this word for word. You guys, the big thing to know, the documentation. You guys have been making documentation as you go, which is good. At this point, whatever you put into your documentation for your game is what's going to be expected upon final delivery. Not necessarily milestone 3, but at the end of the semester, final delivery of the game. Think hard about all the features you wanted to put in. Start drawing out how you might be able to implement them. Start kind of thinking about the code behind the idea. You guys have the idea, really drill down that idea into like the little pieces, break it down into little pieces and think, how can I implement in Java, and then how do these pieces come together within the code? If you get stuck, talk to me. There will be some stuff that you just won't be able to do with what you've given now. Obviously, like you can't do anything graphical because it's going to be text-based over the console. I haven't taught you guys how to use the graphical elements in Java yet, and you're not going to learn that for a little bit. I have suggestions here for where you should start. And I talk a little bit about how I might recommend you guys go about building these things. I'll talk about that a little bit throughout the class. But if you're interested, you can read through here. But the basic idea, you have a combat loop. Start breaking that up into classes. You know, if you think about it in the combat loop, you've got, we can call them characters. So you got the player character and you've got the monsters. Maybe you have equipment and weapons and stuff. Maybe you'll want to think about creating objects for those. And it'll be easier to describe anything, especially the combat loop. I would really recommend starting with breaking that combat loop into multiple classes. Having a class that just runs a combat encounter with like a core while loop within it. Not necessarily a main method, but just like here's like a method for the core loop, and then all the sub methods out of that like calculate, okay, damage was taken, how much damage was taken, who are we applying the damage to, etc. And then actually even before that, create the smallest piece, which is the characters. Every character should have a Boolean tag of like, is this a player? Is this an instance of a player? Is this a, and that's just to know like, which of your characters is players or whatever, but I don't want to actually, sorry, I know I'm like backtracking a lot. The logic of that can vary. You can have just a generic character class and your game knows that this one variable is the character, and then your monsters you can create dynamically. But anyways, your character schematic should have like the name, the maximum health, the current health, any kind of resources that maybe your combat loop requires. It should have their abilities on there, methods that like calculate damage for their abilities, their own abilities. That way, all you have to do whenever in a combat loop is you just call the character and then use the method, use ability, and then give them which ability the user wanted to use, or whichever ability you want the monster to use, and then it'll calculate its damage based off that ability. What else? And then after you made that tiniest piece, I would go on to building the combat loop itself. And keep in mind, when you're creating these, the generic character objects, think about how you want your implementation to be. Do you want a different object for the player character? Do you want a different class for the monsters? Do you want to bundle them all up together in one class? remember what we talked about last week? Your class is like a blueprint schematic. So think about the object in like a physical sense, in a holistic sense in your game, and then try to isolate the different elements. When I was teaching a Python class, one of the examples I gave was of how to isolate the easiest. I pulled up the Pokemon Battle UI. Let's do that real quick. Like right here, right? And then I have the students kind of think about, what are the different variables in here? You know, if we think about it, fight, like all these are different methods maybe. They each have different things they can do. There is if you think about this Pokemon here, the way we represent Bluffin is, you know, he's got a variable name, he's got a Boolean gender, he's got integer health, he's got an integer level, and what else? You know, he's probably got some functions for his abilities that he has available to him. Same thing with the Florabri here. Basically what I'm trying to get at is start with the real world thing and try to break it up. Try to break it up into different elements. Try to identify what are the parts in this. What makes this up. It's like a dissection almost. Does that kind of make sense? Give me a thumbs up if you understand that, thumbs down if you don't at all, and then clap if you're like following. Katie, you raised the hand. Were you gonna ask a question or were you like thumbs upping? Those of you who are raising your hand, like, are you raising your hand because you don't get it, or are you trying to do the thumbs up? Okay, gotcha. Okay, most of you do understand the concept, so that's good. And that skill is really at the core of all computer developing. I know it might seem silly to you guys now, but really that's all coding is just looking at a macro picture and just dividing it into a bunch of bite-sized pieces, just breaking it up into its anatomical parts that are represented through data types, custom objects, you know, thinking about their states and behaviors, right? We can think about that right here with Bluffin's states and behaviors. Maybe Bluffin's behaviors are that it can tackle, that it can use, I don't know, water spout, or I haven't played Pokemon in 10 years, so I have no idea. Maybe Bluffin's states are his name, his health, his sex, his level, etc. Right? This idea of states and behaviors is really at the core of object-oriented programming. Anything in the world, we can look at it and divide into states and behaviors. Like my car is blue, that's a state. My car has 4 doors, that's a state. My car, you know, can go vroom vroom or honk honk, you know, like those are the behaviors, etc. Right, you guys get the idea, hopefully. Let us pull up some code, and I can just code some stuff to help give you guys an idea. I'm hesitant to write code that does what's in the milestone. I really regret doing that for the pre-lab, because then a bunch of people for the combat encounters just copy pasted my code, but it was clear they didn't understand what was going on in it. And I mean, they lost points for it, or, you know, they just copy pasted my code and then didn't really add anything. And I felt like, oh, well, I just gave you this one as a freebie. So I probably won't do that in the future. And yeah, we're probably not going to do that today. We will, however, talk about some stuff general to classes. I want to show you guys a couple of things. For one, sorry, real quick. Everyone understands what's required with a milestone. You're going to take your isolated exploration, and you're going to take your isolated combat loop and combine those together. What I recommend you guys do is have your exploration be the main game loop, and then any room object where there's a fight, that's when the combat encounter kicks in. That's when you'll initiate a new instance of the combat driver, or whatever you want to call it. And that's actually a good segue to talk about, what do I mean when I say, what do I mean when I say the driver class? And that's probably best done through some examples. I'm going to make a very, very, very basic, oh fuck, now I have like combat on my head. Okay, I'm going to make a very, very basic like Pokemon encounter, okay? So we're going to have tall grass. Private Boolean has combat. And then public tall grass. Boolean has combat. This dot has combat is equal to has combat. Okay. And then we'll also create int. You're just going to print out dynamically. And then create a new class, Pokemon. And what are some states of Pokemon? Give me some states of Pokemon, guys. We want to represent a generic Pokemon. We're going to ignore type for now. That is a state, but we're going to ignore it for now, just to keep things simple. Yeah, int level, let's say. What else? HP, yep, max HP. Current HP. Yep. Boolean is male. What else? Those would be behaviors. Because the attacks a Pokemon can do are the behaviors that it exhibits. Right? Even simpler, guys. What's one thing here that we're missing? Name, exactly. String name. All right, and then we're gonna have a constructor, public Pokemon, string name, int level, int max HP, Lillian is male. And I'm gonna keep these public just because I don't wanna deal with maybe I'll make it private just to show you guys encapsulation. The reason why I make these private is for something called encapsulation. The idea of encapsulation is you as a developer want full control over which data fields get accessed by who and when. There are things that people who try to hack your code can do. They can feed malicious code into your game to try and hack it. So one good way to ensure that it's hard to hack our program is to make sure we make fields private. And it's not bad practice to make it all private. You know, there's certain fields that are derived that you can leave open because, you know, even if someone did hack that value and try to change it, it wouldn't necessarily change anything. You know, for instance, like let's say we had an array in here and we had a variable length that always pointed to the length that was always equal to the length of the array. It doesn't matter if the user resets that anytime we call it, it's because it checks the length of the array, it's going to reset itself. But that's down the road. We're just gonna, I just wanted to give like a very easy, maybe contrived example of why we do this private thing. Oops, this dot max HP is equal to max HP. Current HP is equal to max HP. We'll say this. And this dot isMale is equal to isMale. Cool. We've built our constructor for the Pokemon. And oh, we should also have integers for min attack, max attack. Int min attack, int max attack. This dot min, min, and then this dot max is equal to max HP. Oops, nope, max attack. Cool. And I'm just gonna say public void or int attack, and then it's just gonna return it's gonna return a random integer between Java how to generate random int in range. I'll answer your question here in a second, Nabil. Oh, thank you. Max attack. Okay, cool. Random max attack, and attack, and plus minimum attack. Okay, cool. And if you guys are curious about this, you can just Google what I Googled and read the Bill Dung article that explains why it works. Why is line 12 different? The reason why it's different is because I don't, if you look at here, the parameters that we're taking, we're not taking a current HP because current HP is a derived value from max HP. So its initial value should equal whatever our max HP is. You could just as easily have, you know, int current HP. Let's say you want your Pokemon to start at lower HP, but I don't want that. So I'm always just going to set initially, because the constructor is only called once to create the instance. Once when we've initialized or instantiated this instance of Pokemon, whenever we create a new Pokemon, that is, I want the current HP to equal whatever the max HP is. Does that answer your question, Nabil? Cool. Okay, so here's a Pokemon. They have all these states about them, and then their one behaviors that they can attack. And then the tall grass, I'm gonna have private Pokemon. Pokemons, we'll call it. And if it has combat, let's say if this dot has combat, then we want to create up to 4 Pokemon. Let's say int num Pokemon is equal to that. I'm gonna change a couple of things about this, maybe for now. That's fine. Is equal to 4 minus 1 plus 1. And then Pokemons is equal to new Pokemon array, initialize to the number of Pokemon that we want. Then for int I equals 0. Now we're going to construct our random Pokemon. 0. I is less than Pokemon's.length, I plus plus. And then I'm going to say so int min attack is equal to 1, int max attack is equal to somewhere, let's say between 8, or no, that's too high, between 5 and 3. So it's going to create a random integer between 5 and 3. And we'll say int max HP is also equal to, let's say they're going to have somewhere between 10 and 5 health, right? We'll just say that. And then what else do we need to make here? Boolean is male is equal to int math.random modulo 2 is equal to 0. So basically here what I'm generating a random integer. It's going to be a 1 or 0. If it's 1, this is going to be false. If it's 0, it's going to be true. And basically I'm just creating a Boolean expression here so that I can assign a random, whether this Pokemon is a male or female. And int level, I'm actually going to get rid of level. I don't want to worry about level right now. Here's level. Let's just get rid of level and name. No, we do want to keep name. Okay. And then string name is equal to just doing that for now. Or we'll just make it equal to I. So that the Pokemon's name is always their index. We'll cast that to integer to string I. Cool. Cool. Well, I believe that's it. All right, cool. So let's break down this code. Basically, anytime I create tall grass, I'm going to say true or false, that it has combat or not. And if it has combat in the constructor, then we're just going to create a random encounter. This implementation, you guys can easily, if you're doing random encounters, you can do this in your rooms. Or you can make an implementation so that you can actually populate this array yourself with creatures for the player to fight in your dungeon crawler. But on we go. Script for random Pokemon. Oh, and then I'm going to say Pokemons. Creating random stats for our Pokemon. And adding our Pokemon to the encounter table. We'll call it Pokemons at I is equal to new Pokemon and string name. We don't have a level anymore, buddy. Oh, whoops, yes we do. I'm gonna remove it from here. Help me out. Show me the thing. Never mind. Max HP. There we go. I'm just gonna move these windows down. Holy shit. Sorry, y'all, I'm working on the garage today, so garage door just opened. Okay. Do we need anything else here? Okay. Now we'll just leave it as that. So what I've created so far are the two small pieces. I've created the Pokemon, and I've created the place that a Pokemon to fight could be hidden, right? And then I'm gonna make the main game new channel class Pokemon game driver. We'll call it that. And it's gonna have our main method. Main string args. I'm actually gonna rename this refactor, rename. If anyone has questions along the way, just let me know, and I will do my best to answer them. Pokemon game driver, game driver. Or we'll just call it game. Game. And that's how we'll know this is the main entry point. And I want to create a map. So I'm going to go in here and create a new class called map. And this is going to define where the user can move, which tall grasses that the user can go into, etc. And I'm arbitrarily going to put it over here, right here. So I'm just going to make a 2D array. I'm going to hard code it. Public, private, tall grass, map, and then we generate. I'm going to write a default constructor. I don't want to give any stuff here. And then we're going to proceed with making a random map. So, and we'll just say this is a new tall grass array, and we're just going to have it be 3 by 3 for now, just because. So on we proceed for int I equals 0, I is less than map.length, I plus plus, and then for int j equals 0, j is less than map 0.length, j plus plus. Right now we're generating a random map. And does my tall grass have any? No, just if it has combat. Okay, cool. Map I at ij is equal to new. I'm actually going to start these. I'm going to do this actually. If I equals 0 and j equals 0. So if we're at 0, 0, this is the entry point. I don't want combat on this one. I don't want the first one the user starts in to be in combat. I will say map, I will say Boolean has combat is equal to math random modulo 2 is equal to 0. So again, we're generating, we're just using math random to generate a random Boolean. And I'm going to say here has combat is equal to false. And then over here, we're going to say map at ij is equal to new tall grass has combat. And bam, we are going to dynamically generate a map that maybe some of them have combat, some of them don't. And within our map, I'm just going to say int how to represent the player. How do I want to represent the player? I'll just make a new class for the player. And the player will be a different Pokemon. Pokemon player. We can copy a lot of the stuff over from Pokemon and edit it accordingly. Actually, string. It doesn't string it. Okay. Player. And we don't really care about the player's gender in this case. And we also want private int row column. Let's say. And just for the sake of practice, I'm going to make these just public, just because. And then we'll set the, we don't have to set those in the constructor. We'll set those in the game. So first we're going to create our player. Player is equal to new player Turk. And then let's Pokemon max HP, and we'll just say my max HP is 30. Boolean is male is true because I'm a dude. And then min attack 7. Max attack 10. These are just arbitrary numbers. Player.row is equal to 0. Player.column is equal to 0. So we started 0, 0 on the map. And then we start our while loop. Public string get movable directions, int row, int column. Any questions thus far? I know I'm just like live coding. Are you guys able to follow along, or are you just totally lost on what I'm doing? Okay, cool. Use the raise your hand function. If at any point like you just don't understand, there's like a raise hand function. It alerts me that you raise your hand, and then I'll, take your questions. Or you can always just start talking to, and then I'll take your questions. Say string directions is equal to new string 4 because there's 4 cardinal directions. Okay. And then, so we're going to say int I equals 0. Here we're going to say if row plus 1, meaning we go down a row, we go south, is less than map.length, because map.length gives us the total number of rows. So if we go down 1 and we're still in the map, then we say we're spacing out, sorry. If we go down 1 and we're still in, we're going to say I plus plus, oops, directions at I is equal to south. You can go south, and I'm going to say I plus plus. And we're going to say if row minus 1 is less than, greater than or equal to 0, then that means we can go north 1. North. And we're going to repeat these for int column plus 1. If column plus 1, if we move the column up 1, what direction do we move in? If the column value gets incremented by 1, what direction are we moving in? Because if we increment the, right, which would be east. And then to check this, if it's still within the map, how do we check if this guy, if column +1, how do we check if that's still within the map? Map.length checks the rows. How do we check the columns in a 2D array? How do we check the length of the columns in a 2D array? Yep. Map 0.length. It could be I, it could be 0. Actually, it can't be I because if, well, no, never mind. I is always going to be within, but 0 is always your best bet because like all of your map lengths, all your column lengths are going to be the same. So yeah. Directions, I is equal to east, I ++, and then if column minus 1 is greater than or equal to 0, then they can go west. I is equal to west, I ++. Oh, I forgot a semicolon over here. Okay. Then we're gonna turn directions, and just for the else, I want to say else directions at I, go to that just to be explicit, or we'll say null I ++, and we're going to copy that for all of these. And just to be efficient, what we can do is we can, because we're going to increment I no matter what, we can just pull it out here. And if I wanted to be really neat, I would actually remove these these curly braces, because you can write your if-else statements like this. I just think it looks neater. It's honestly personal preference. I personally just like this better, and I'm very picky about my formatting. But you don't have to do your code this way, obviously. This is, again, personal preference for me. Cool. Okay. We actually don't need to increment I here. And then basically this gives us all the movable directions. And we can say, we'll just handle it in the driver class for now. Public void print movable directions, string directions for direction and string and directions. For each string and directions, we're going to say if string not equal null, then we're going to print out system out print string and then a space after it. And then at the very end of it, we'll print out a new line. And then we'll say void pick direction, string direction. And then I'm going to say, we're going to have a method here called public void move direction, string direction. And we'll say switch direction to uppercase. And the reason why we make it uppercase is that regardless of however the user decides to enter in north, south, east, west, whether they do it all capitals, no capitals, whatever, we can make our program case insensitive, meaning it doesn't matter what the case is, we know what they're saying. And then case north. So if they move north, if they want to move north, how do we adjust the rows and columns? Rows minus 1, exactly. Rows minus equals 1. Oops, row minus equals 1. Break. Okay, south. Column. Oops, sorry. Row plus equals 1. And I could also do row plus plus. I could even do like row plus plus, row minus minus as well. Break. What if they want to move east? How do we represent that? Column plus plus, exactly. Plus plus, break, and then case west, column minus minus, break, and then if I say default, it's not print, error. And I'm gonna be okay with my game crashing. If we can't get it to work, that's okay. My game can just stop working, totally fine. And we're also going to ignore the fact that maybe the user will enter a direction that's not on the list. We'll just assume our user is going to comply. You might want to have error handling in yours, not necessarily like for the milestone, but later down the road when you learn about error handling, learn more about error handling, I should say. But for now, it's okay to just assume that your player is going to be compliant. And we're just going to say player dot move direction. What I've created here is kind of like a helper function. Basically, it's moving data that exists into this class and moving that data into the player class so that the player can interact with it. Don't know why that doesn't light up. This should be lighting up. Anyways, so let's kind of think about our main loop here. And we'll say the game ends when the player reaches the bottom, the very last part of our array, which is 2, 2. So while player dot row does not equal 2 and player dot column does not equal 2. So while player is not a 2, 2, we will say we'll have our main game loop here. Main game loop. Okay, and basically each iteration we're going to check if, and we need a way to query the map, if public Boolean check combat int row int column return map row column has public boolean has combat, return as combat. Cool. Cool, and that is how we will do that. So if check combat, map. Oh shit, how do we get our map? We didn't build our map. Let's see over here, build our objects. And then map is equal to new map. I'll say map.checkCombat. Player.row, player.column. If it has combat, then I'm gonna make a new piece of code here called, oops, new class, call it combat driver. So basically, my default game, my base game is that the player gets to move around this map. And I tell them, hey, you can move in these directions. The extra part of it, the next layer of the game, is that there's combat encounters in random places. So if one of these tall grass has a combat encounter, then I need a way to be able to resolve that combat. So let's say there's a combat driver, and we need a way to pass in both sides, the player and the monsters that they're facing. So let's do it. Public combat driver as player, and then Pokemon, like these privates. Pokemon's player, Pokemon's, and we'll say this dot player is equal to player, this dot Pokemon's is equal to Pokemon's. So that'll be our initialization, and then we'll say public void run, and that'll run the combat. So we'll say while int this dot num, actually I don't need to do this, int num Pokemons. Num Pokemons is equal to Pokemons dot length, while player dot get health, get HP, public int get HP, return current HP. Oh, we also want methods here probably to take damage. Let's say public void set HP into HP. Current HP is equal to HP. And then we'll say public int attack is same thing as we did for the Pokemon. This thing right here. Cool. Any questions so far? I know I'm kind of like just plowing through this and not making too much meaningful commentary, just kind of muttering to myself as I go. Feel free to like raise your hand or stop or ask a question at any time. Player HP is greater than 0, so while the player is alive, or while the player's alive and while the num Pokemons is greater than 0. So while all the Pokemon are alive and while the player's alive, we want to keep going through with this. And we'll have an integer int round equals 1. Boolean player turn is equal to true, while round is even. Oops, if round is even, player turn is equal to false. Trying to think. I want to also give just because I want to make it a game, I want to give the user an option to, or you know what? Nah, we'll just make it a simulation. Fuck it. If player turn, take the player's turn over here. Otherwise, Pokemon's turn down there. So we will say on the player's turn, the player is going to attack the Pokemon. How should I do this? Int I equals 0. And then I'm going to take turns.
You put the brackets at 19. Or yeah.
Here, we'll do that. Sorry, I'm just trying to thought how to do this. So when it's the player's turn, the player is going to attack the Pokemon. So we're going to say in we have a Pokemon set HP. No, we don't. Copy from player. Okay. Oh, I forgot I have it open over here too. So it's the player's turn. We're going to say int player damage is equal to player dot attack. And then Pokemon's at I, set HP is equal to we're going to get the current HP minus the player damage. And likewise, we're going to say for this one, Pokemon damage is equal to Pokemon's I dot attack. And then we're going to set the player HP is equal to player dot get HP minus that. We're also going to check if Pokemon's I dot get HP is less than 0, less than or equal to 0, excuse me. Then we simply decrement num Pokemons and we increment our I. Yeah, that should work. So if map.check come up, if there's combat, then we're going to create and I think we can even make this static. No, I was going to break a bunch of stuff. Okay, I'm going to say new combat driver dot run. No, we need to actually initialize a new combat driver. And we'll say I'm going to do this in one line, and then if you guys are confused, we can break it down. Map dot. Let's put a map dot public Pokemon get Pokemons int row int column, and we're going to say return public Pokemon get Pokemons return. Oh, this is the wrong. Oops, that's the wrong class. Tall grass. Let's say public Pokemon get Pokemons return Pokemons. Cool. Return map at row column dot get Pokemons. So as you guys can see, we have a little chain of carrying data because the data we want is housed in tall grass. We want to get what Pokemons are dwelling within this tall grass. And we pass it back to map because map can be accessed by our game driver over here. Map dot get Pokemons at player row player dot column. So we've here in one line, we've created a new instance of combat driver, and because our combat driver has a explicit constructor, we need to give it these parameters. So we give it our player, and then we also give it the collection of Pokemon that reside within there, and we know that there should be this Pokemon thing initialized because we check to see if there's combat there. And anytime there's combat, and we know that that's the case because in the tall grass, anytime there's combat, we randomly create a bunch of Pokemon here, right? And in your games, you'd want to try to find a way so that the player can choose which creature to attack, because right now I'm just creating a simulation, right? My player has zero interactivity. If you turn in something like, if you copy this code and turn it in, you're not going to get very many points because you just created a simulation and you've really just copied my code. So if you just copy paste and turn this in for your milestone, you're not going to get points. You're free to use this, and I'm not going to post the code. I do want you guys to go through and like code along with me and get that practiced. So I'm not going to offer this up for you guys to copy paste. I want you guys to, read through the code, make it your own, and understand what the code does. And the best way I think to do that is actually to watch me build it and not just copy the code and then ask me things that I answered in this recording later on Discord. Where were we? Okay. So we're going to check at the beginning of each round. We're going to check if where the user has combat, and then we're going to run the combat, and then after that, hold on. There should be two conditions to check here. We should make sure one condition is that the player is not at the end point, and the other one should be that player.get HP is greater than 0. These are the two conditions that we want for our game to keep running. The player needs to be alive, and these need to be the case. Or actually, you know what? We could do it over here. Sorry, we don't even need to necessarily check it there because we can just check it right here. If player.get HP is less than or equal to 0, it's going to print, you died, game over. And then we break. Otherwise, we continue by, and we should actually import scanner, import Java util scanner, scanner. Should initialize that out here. Scanner sc equals new scanner system.in. And who can tell me why I'm initializing the scanner outside of the loop? Why am I building this object outside of the loop? Why is that important? Can anyone take a guess? It's part of it. You do have to close it. But if we, I need to pass somewhere else. So if we were in a while loop, yes, Daniel, exactly, because it will try to initialize the scanner every time, and that might cause errors. Our scanner might start functioning weirdly. Even if I were to, yeah, it being out here is not because I want to pass it or anything like that. It's because if I had it initialized in here, then Java will create a new scanner every time. And creating new instances of scanner with the system.in, that might mess with my, that'll mess with my input stream. And I'll get these really weird errors of scanner not working. So we want to make sure our scanner's built first, and then we can keep referencing it within the main method. Do you guys get that? Because that is pretty key. If you don't get it, hit no and we'll break it down. But I need you guys to respond. Otherwise, I'm going to assume you get it and we're going to move on. Okay, cool. Cool, cool, cool. So over here, we're going to say print movable directions. Wait, why do I have that? Oh, right. So we're going to say print movable directions. We're going to say map.get movable directions, player row, player column. So here we we just have to make these ones static because we're calling them directly from a static method. That is okay. So we get the print movable directions, and then we're going to say pick direction, player, and then we're going to give them the sc.next line. And we're just going to assume the player is compliant. They're not going to be doing anything weird to break our game, so I'm not going to make an error check because I'm just going to assume everything is A-OK. So that's the direction they move in next. So they pick it, then the player moves in that direction. Cool. Okay. Awesome. Awesome, awesome, awesome. Oh, something quickly to note, because you might. So in my game right now, when we ask the user to pick a direction, right? Pick one of the directions below to move in. When our user picks a direction, if they pick something That's not north, south, east, or west, or something goes wrong or weird, and it doesn't recognize any of these, and it defaults. Then we go back to the start of the loop, and the player is still in the same location. Now, if the location they were in had combat, when this runs, it's going to say, yo, this area in the map still has combat. And when they go to get the Pokemons, the user's going to have to do the combat all over again. Excuse me. The user will have to do the combat all over again. And the reason for that is because when we, over here in the combat driver, when we copy this Pokemon's over, we're just creating a copy from the tall grass. We're not directly accessing this Pokemon's array in the tall grass. We're just creating a copy of it and giving it to the combat driver. So the changes we make to the Pokemon's here do not reflect the changes we've made to the Pokemon's in here. So combat's going to run all over again. And we'll just say combat encounter. And otherwise, we'll just assume you're gonna die. You won. But yeah, does everyone get what I mean by the copy? The Pokemon's array here gets copied. It's not the original, it's a copy. And that's how Java works. You don't those of you who come from C++ backgrounds, you understand the concept of sending by reference. When you send by reference, you send the actual object over. Java sends by value, meaning it makes a copy of the value you want to send and then sends that over through the method. Is that making sense? This is kind of an important concept, so I'm happy to spend the last like 10 minutes of class talking about it or whatever if you guys want. Does that make sense? Okay. It's very important that you guys understand that concept because I guarantee you it's going to come up with some of you guys in your homework as you do the milestones. So why don't we run this, huh? Let's try running the thing that we built. Edit configurations and make a new build. I call it Pokemon game. Game. There we go. Okay. Let's hope it runs let's hope it works the first time. Oh. I'll say this. That way this doesn't print every single time. If there was combat and the player survived. We can move south or east. Let's go east. Let's go east one more time. Oh, I guess we win. Oh. Right. This just makes it so that if we come to either of the edges, it's okay for now. I mean, it's fine. Our dungeon has like an endpoint. It's not a singular endpoint. But you guys will need to come up with some idea of how to make sure you're in the location and not yeah. The way to fix this would be what? How would you, so right now, okay, what's happening right now is, and I'll go to the whiteboard and show it. So we have our array here, right? Our 2D array, 0, 1, 2, 0, 1, 2. So we're checking so long as the row is not equal to 2, meaning so long as row is not equal to 2, and so long as the column is not equal to 2, the game will keep going. That leaves only these 2 squares for us to play with, or only these 4 squares to play with. How would we fix this? how would we write a conditional statement so that it's only this 2 square? That's, how do we check to see if this is if the player is in this square? How would we, yeah, give me some ideas, guys. How do we change this up? Because we know that what we have right now, if row does not equal to 2 and column does not equal to 2, it doesn't work, right? Because this if statement makes it so that so long as we're not in this region, the game will keep going. But we don't want that. We want to make sure the game only ends when we're here. How do we do that? What's the if condition, guys? It's a very small fix. How do we check to make sure the player is exactly at 2-2? Because that's the change I want, is I want to only end the game if our character is exactly at 2-2. How do we check for that? Exactly. Ronnie is exactly correct. So I'm going to come here and change my thing. I'm going to say, sorry, I'm moving like the Zoom windows around so you guys can actually see in the recording what I'm writing. So we're going to say this one goes forever. And then at the beginning of the loop, we're going to check if player.row is equal to 2 and player.column is equal to 2. Then we break. Let's say print, you've reached the end. Then we break. Game over. Okie doke. So let's run the game again. Pick one of the directions below to move in. East. Let's go east. South. West. South. Okay, so something's wrong that nothing is in combat. So just to demonstrate the combat, that's something that's going to require some more debugging and probably a change in logic over here. Or how are we generating that? Yeah, that's going to change some stuff, require some changing over here probably. So probably something's wrong with that. But for now, we'll just say is equal to true. So that way, once when the game starts, say, put these over here after the combat. We'll make these checks. And then, yeah, so the very first square is going to have a combat encounter. So we run the game. Yep, there's a combat encounter, we win, and then we can move east again. We're going to go south. I'm going to go south again, and we've reached the end of the game and we win. Cool. Very, very lame game, but a lot of the concepts that you guys will need for your milestone 3 are in there. Like I said, if you just copy my code and use that, you are not going to get a good grade for the milestone. You are more than welcome to use as a template and as ideas, but make the game your own. Don't just copy paste what I did. And obviously there's things in here that you will need to account for. Like you might want to think about what happens if a user gives improper input? You know, how are you going to handle that? I'll say because it's an alpha, you can just have it be that if a user gives you bad input, you can just tell them, yo, that was a bad input, and then end the entire game. That's totally okay. But just be aware that, you know, there might be, think about some conditions, and it can be totally okay if like a user gives bad input, the game just crashes and ends. That's totally okay for the alpha release. You'll be thinking about error handling towards the end of the semester some more. Did this demo help? Has this kind of cleared up a little bit for you guys how to work with objects? Or it just be like, whoosh. Give me a thumbs up if this was like super helpful, and give me a thumbs down if it just flew over your head. Okay, cool. I'm glad it helped out a lot of guys. Yeah, definitely refer to this lecture a lot. Watch this a couple of times. I think once when you've watched it a few times, a lot of what's expected of you for the Milestone 3 will sink in, and it'll hopefully give you a good template of how to build your own game. But I'm very glad that it helped you guys. I'm glad you guys felt like you learned. Okay, I don't want to keep you too long because I do think the class ends at 11:40, and we are now officially 1 minute over. So I will wish you guys a good weekend and a good Thanksgiving break.
Thank you. Likewise.
Thanks,
Thanks.
Professor.
Thanks, guys. Have a good time.